Welcome back. In the second part of our Omnis Studio course, we will now fine-tune our remote form and show icons and pictures in the list. We're now using the database session that we created within the Omnis Studio developer version. Let's have again a look in the session manager. The host name is the path name of the SQLite database, Cucina Piccola.db. When Omnis is closed and reopened, the database is also closed but not reopened. Therefore, we need to develop a logon method into our application. When a user connects with a mobile device or through the web browser to the Omnis application, the first method that is executed in the construct of the remote task is in the construct of the remote task. Double-click to edit. Here we are now going to develop the logon. Just type do and the command do appears. We can enter, for instance, a function. Type F9 or Command 9 on the Mac. This opens the catalog where we have an overview of variables, constants, functions, and more. Here you can see the function group that divides into subgroups. In the subgroup string, for example, you will find string functions. In fileops, you will find functions dealing with files on your file system. We now need the function $split path name that will split the whole path name of our library into several parts. You can either drag the function into your code editor or just start typing the function, and the notation helper will assist you while you type. $clib is the reference to the current library. We would like to know its path name. While typing, it also shows the expected parameters. We add those as prospective variables. The variables that are not declared yet are marked with a red underline, and you can use this little button down here to declare the variable on the fly. We have now declared local variables that you can see in the variable declaration area at the top of the editor in the local section. Alternatively, you can declare your variables right there. A shift click on the left column of the editor starts the debugger. Use the Step In button to step through your code. We can now see the contents of the variables when we hover over them with a mouse pointer. Drive is only used on Windows platform. Please select the next line and enter C for the calculate command. Type in path name and then use tab. We're now using the const function to concatenate. To concatenate the contents of the variable drive and directory and add a string in single quotes, Cucina _Piccola.db. The go point, which is the small green arrow, shows that we are still in debug mode. Therefore, we can now step over this line and inspect the result. Use shift click if necessary. You can stop the debug mode using the context menu at the method stack. Next, we declare a task variable with the name tsessionObj. The type is object. The subtype can be used to access an external object, for example, a Java class. In that case, we are going to use the Omnis SQLite database access module. Add a do command in the next line. A right mouse click onto the variable allows to open its interface manager that shows all properties and methods of this object. We would need the $logon method that we drag and drop into the calculation box of the do command. We probably better rename the variable path name into host name. You will see that it's automatically done for us inside the code. In order to implement an error handler, we need another variable as a return parameter of type Boolean. Add returns to the end of the command and enter the OK variable. We are now using the OK variable in the if statement, and the next line will be else. And finally, we are using the command quit method in order to return an error text. And then do not forget the end if. Next, we select the table class and assign its design task name to the remote task, because Omnis needs to know during development which task we are going to use in runtime. In the construct method of the table class, there is a line of code that tells the instance what database session to be used. We are going to replace this now using the new task variable inside the $assign. In order to test this, we can put a breakpoint inside the construct of the remote task. Now let us open the remote form using test form from its context menu. The browser opens and waits because the execution of the Omnis code stops at the breakpoint. We can now step line by line with the step over button. Oh no, the return parameter tells us that the logon was not successful. Let's have a look at the session object. It is a variable in its context menu. Here we'll find the error in the error text. It tells us that the number of parameters is incorrect. Let's have a look again into the session manager of the session object. In addition to the host name, we also need username and password, since those are mandatory. The fourth one is optional because it is marked with square brackets. Since SQLite does not support username and password, we just add 2 commas for empty parameters. Click on Go to test the error handling. The browser now shows the error text that were returned. When you reload the browser, you can again test. The debugger stops again at the breakpoint, step over, and finally we click on Go again. Now the browser shows the data. Let us tidy up our library a little bit now. Create a folder database layer where we are going to put the data-bound classes such as table classes. To make it easier for you, I have prepared some classes that you can copy from a second library. Please open the library resource LBS. First, copy only the class TA Super that will be our superclass in the future. Just drag and drop it from the resource library into the new folder of your CP library. A double click onto the new class opens the editor for this class. In its construct method, you will see the assignment of the session object that we have previously done in the other table class. We're now going to inherit the table class TA tables from the new superclass TA super. Select TA tables and find TA super in the drop list of the superclass property. When you now open TA tables, you will see that all public methods are inherited. Only the construct method needs to be inherited manually since there was already some code line. Use the context menu on the method name to inherit. You will be prompted since it deletes the current code. The method name is now in blue. Double-click on the construct method opens the superclass code. Likewise, you can inherit single properties. For example, the design task property. Use the context menu directly at the property name. Finally, please copy the rest of the table classes, the two schema classes invoices and orders, and the object class OwnNavigation into the database layer folder of the CP library. You can now close the resource library. To see more details, you can change your view. In the details view, you can immediately see what superclass is assigned for each class. Let's have a look at the new object class that we copied. There's a method $getGroupList that returns a nested list. The second method returns a list of products. As we can see from the subtypes of the lists, it uses methods from the imported table classes. It loads products for each product group into a sublist, and therefore it creates a nested list too. We will now implement this into our remote form JS serve. A double click opens the form. Another double click onto the grid object takes us to its event method. Using the context menu onto the grid, you will create a new method directly at the grid object. We call it $setMenu. Click on parameter in order to declare a new parameter. We will call it p_offset. We will call this method later from its $event method, and the offset controls that we want to go one level deeper in the menu with +1 when the user clicks on the grid. The instance variable iManuLevel is needed to remember the current manual level. Short integer is sufficient. Another instance variable is going to be the header text that is shown to the user that the staff knows which table has been chosen in the first manual level. Next, we are going to declare an object variable iNavObj. Akin the session object, we now use the object class OwnNavigation in our library as a subtype instead, an external class. Select an empty code line and type C in order to get the calculate command. First we calculate the offset. Control or Command N for the next line, then type switch. The switch command will be used to compare the value of iManuLevel. In the next line we use the case command where we compare with level 1. This is the highest level. Then we calculate the header with an empty string. We actually clear the variable. In addition, we need to remember which list variable will be in use. Therefore, we declare another character variable as an instance variable, and we put in the name of the table list, actually iTableList, into iCurrentListName. In the next line, we add another case command where we check level 2. This time we put the table name into the header text. We can use the con function using the string table in quotes, and as a second parameter, the current line number of iTable list. The list name will be group list. And yes, we need to declare this list too. Make sure it will be an instance variable. We don't need any subtype because the list will be delivered from the navigation object. Use the do command and enter the object variable inavObj. Then enter the get group list $getGroupList method. As a parameter, we pass the table number, which is the current line number of iTable list. As the return parameter, we enter the iGroupList variable. In the third level, we need to determine if this is an order, meaning we are actually in the first group. We will check the line number of the group list. In that case, we fetch the product list from the navigation object using $getProductList. The parameter from the sublist determines whether it is in the food or drinks group. As a return, we will get the product list that is not yet declared. We need to remember the list name. When we are in the checkout group, actually not in the order area, we need to check if this is the request for the order summary. Let us declare another instance variable of type row, iOrderRow, based on the table class TAOrders. That table class contains a method $getGroupList that we call and pass in the current table number. The return is the summary list that also needs to be declared, but without any subtype. Again, we need to remember the name of the actual list in use. Then we close the if statements using the two end ifs. The default branch will be used when no case command was true. In that case, we are going to calculate the manual level backwards as we subtract the offset. This will only happen if the user clicks on a row within the highest manual level. Let us end the switch statement typing an end switch. Finally, we want to assign the current field, actually the grid, a new data name. The list name that is currently in the variable iCurrentListName. We now need to call this method. This will be done from the $event method of the grid object. Enter on and choose from the event list evClick. In the next line, we would need a do. We're going to address the recipient using $cfield, the current field, because the method sticks on the same field. Let us brush up the remote form a little bit. Get a page pane object from the component store. We're going to use this as a container field. Please call it top_container. To make the page pane stick on the top of the form, please assign the edge float property. Make sure to select set for all layout breakpoints and then choose KAF Posen Top Toolbar. The container now sticks on the top within every layout. We just need to assign the height of it. The grid object now gets the edge float KF post client for all layout breakpoints, and therefore it takes the rest of the space. The page pane can then be used to add a header field. The field is going to show the value of the variable iHeader if it is assigned to its data name property. Let us center the field. If the field is not visible within a smaller layout, then you can use the field list to select it. And simply assign the left property to make it visible. Let us add a button that will allow to jump back into the previous menu level. We will call it back button, and we enter back into the text property. This button is going to call the set menu method of the grid from its $event method. Actually with a -1 as a parameter because of the offset that is declared in the recipient method. Oh, I just realized that the offset parameter inside the $event method of the grid needs to be set to +1. Let us put in a breakpoint. Note, do this at the do command, not at the on command. Let us test with Control or Command T. Something else is missing. The menu level ought to be initial set to 1 because when the first open it, we are on level 1. Please put in 1 in the column initial of the variable. With the step in, we will step into a $set menu of the current field. Hovering the mouse pointer onto the variable allows us to see what the value is now. The menu level is now set to 2 and the next list variable will be filled. Now press go in order to execute the rest of the code lines. We can now see the result within the browser. The back button reloads the table list. Another click on the table list makes it stop again at the breakpoint. Remove it and click go. Now we can see how it behaves. Thanks for joining the second part. In the third part, we're going to develop the buttons and store the records in the database. Bye bye, see you soon.